How are you, everybody? Our lesson today is the part 2 of lesson 1, unit 2, properties of sound waves. Now, last part is about factors affecting the sound intensity. What about these factors? Number 1, distance between ear and sound. 2, amplitude of vibration of sound. 3, the area of the vibrating surface. 4, the medium density. 5, window direction. Number 1, distance between ear and sound source. Okay, if distance between me and you increase, my sound intensity will decrease. So there is inverse proportional between square of distance and sound intensity. If the distance decrease, if you are near to me, my sound intensity will increase. So inverse relation, inverse proportional between square of the distance and the sound intensity. Do you understand me? Inverse relation between sound intensity of sound and square of distance. Excellent. Number 2, the amplitude of vibrating of sound source. There is direct proportional between square of the amplitude and sound intensity. Please compare between the relation of sound intensity with amplitude and with sound, with distance. Sound intensity is directly proportional with square amplitude, but inversely proportional with square distance. Excellent, excellent, excellent. But we want to remember, sound pitch related with frequency and sound intensity related with amplitude. From graph, from figure, you can know which is higher sound intensity according to amplitude and which is higher sound pitch according to frequency. Excellent. Number 2, the area of the vibrating surface. Vibrating surface, we have resonance box like this, amplitude box, and like guitar, musical instruments, the sound intensity increase if the area of sound, if the area of vibrating surface increase. Okay. Number 4, the medium density. There is direct proportional between density of medium and sound intensity. If we have two media like carbon dioxide and air, carbon dioxide is higher in medium density than air. So sound intensity in carbon dioxide is higher than in air, and this is famous give reason. Sound intensity in carbon dioxide is higher than in air. Give reason due to medium density in carbon dioxide is higher than air. Excellent. Last factor, number 5, wind direction. Sound intensity increases if sound waves propagate in the same direction, and it decreases if the sound propagates in opposite direction. Take care, increase when my sound moves with the wind in the same direction, and it decreases when my sound moves in the opposite direction. Do you understand? We have studied earplugs, just for remember, it's made of silicone. Take the shape of external ear canal, used to avoid the noise. This activity to show intensity decreasing by decreasing the medium density and increasing by increasing it. We put clock inside the jar and we can vacuum this jar from air, so the sound of clock will decrease gradually. Okay. Now we will study sound type or sound quality. What's meant by sound type? By which ear can distinguish between different sounds according to their source, even they have equal the intensity and pitch. What's meant by sound intensity? The property by which ear can distinguish between harsh and sharp. By what's meant by sound pitch? The property by which ear can distinguish between strong and weak. So the property by which ear can distinguish between it is consonant words. So okay, if we have two sounds, okay, both of them have the same intensity and pitch, how can differentiate between them? According to tones are called harmonic tones. What's meant by harmonic tones? Listen up. We have two types of tones. One of them is fundamental or simple, like tuning fork. Simple, only fundamental. But there are tones are complex. Complex, what's meant by complex? Fundamental tones with harmonic tones. So harmonic tones accompany with fundamental tones, and the harmonic tones higher in pitch, lower intensity, higher in pitch, lower intensity. Listen, pitch ended with H and the higher begin with H. So higher in pitch and lower intensity. Please, what's meant by harmonic tones? It's a very important definition. It is tones that accompany with fundamental tones which have lower intensity and higher pitch and differ from one instrument to another. Any instrument has harmonic tones. Okay? Sound, types of sound waves. So, types of sound waves. Audible sound, we can hear it. So, because their frequencies ranging from 20 hertz to 20 kilohertz. Listen up. We can hear only the frequencies from 20 to 20 kilohertz, okay? But we can't hear less than 20 hertz or up to 20 kilohertz, higher than 20 kilohertz. Do you understand? So, non-audible sound, infrasonic, this frequency less than 20 hertz, we can't hear it, okay? They accompany the blowing of storms, that preceding rainfall. We can't hear this blowing because it has frequency less than 20 hertz. Number two, ultrasonic. Ultrasonic have frequency higher than 20 kilohertz, so we can't hear it. We hear only between 20 to 20 kilohertz. Less 20 is called infrasonic. Higher 20 kilo is called ultrasonic. We can't hear them. Infrasonic like blowing of storms, but ultrasonic like some animals which can hear them, ducks, dolphin, bats, okay? Life application of ultrasonic waves. Ultrasonic waves is very important. Medical field, breaking down kidney and ureter stones, and we can discover the male prostate gland tumors. We can discover cancer. Oh my God, they are very important. Industrial field, kill some types of bacteria and stop action of some virus. I wish to kill coronavirus. So it's used to sterilize food, water, and milk. Number three, military field, discovering of landmines.